So in the previous video, we were talking about dimension conversion or using just one dimension. So either length or time or volume, all of that. But now we are going to be looking at multiple dimensions. So sometimes you have to convert numbers that involve multiple dimension into another multiple dimension, right? But the rules are the same. Let me just refresh you in the rules that we saw in the previous video. We're talking about you writing all the numbers as fraction, write everything with its unit, arrange unit factors so that each one cancels, so that the unit that you don't want should cancel and you only be left with what you want, right? Or what you're converting to. Numbers on the top multiply and numbers at the bottom divide one another, right? The key, whether it's a multi-dimensional problem, the key is one dimension at a time. Make sure you have one dimension at a time. It's very important. You should have one dimension at a time, right? Now, imagine that someone in America is is riding a bicycle, and at the end of the day, their speed turns out to be 17.2 miles per hour. So someone that is in France or in Canada will want to, because they're not used to the miles, they are not used to the miles. So this person wants to really understand what speed, right, this person was actually driving at. So they will want to convert it to meters per second because that is what they actually understand best, right? One thing you need to understand is whether you're converting 17.2 miles per hour to meters per second, right? It does not change. The speed is the same, right? It's just expressed in a different unit. Now, we have two dimensions in this problem. Mile is a dimension for length, while hour is a dimension for time. So what you need to do is that you need to recognize that each time we say mile per hour is the same as writing it as 17.2 miles divided by 1 hour. Once you've understood that point, you can now choose what dimension you want to convert first. In this case, I want to convert miles first to meters, then I will convert hours to seconds. All right. And so there is this conversion factor that says 1 mile is equal to 1.609 kilometer, right? So you can use that. So you take the mile, you convert to kilometer, and you convert a kilometer to meter. And we know kilo means 1,000, so 1 kilometer is equal to 1,000 meter. Okay. So you bring your conversion factor that is going to enable you to convert mile to kilometer. You see mile will take care of mile and you're left with kilometer, right? Now you bring the next one that enables you to convert from kilometer to meter. So 1 kilometer is equal to 1,000 meter. You bring that in such that the unit cancels. So I arrange my conversion factor such that kilometer cancel kilometer, right? And now I have converted my mile to meter because you see the only unit I have left is the meter right here. All the other units of length have been cancelled out. Now my next dimension I want to convert is hours, and I want to convert hours to minute first, right? Um, and then take it from minutes and convert it to seconds. So I know that in every hour I have 60 minutes, right? I bring it in and I arrange it because I have hour at the denominator. I want to make sure that my 1 hour goes at the numerator so they can cancel one another, right? So this 1 hour will cancel that 1 hour right there. This one cancels this one, and I'm only left with minute. Now I bring in another conversion factor that will enable me to convert from minute to seconds. In every 1 minute, there are 60 seconds. Again, I now arrange the 60 minutes and the 1 hour such that they cancel out. So I have a minute at the denominator. So I want to make sure that my 1 minute, right? I want to make sure that my 1 minute goes at the top and my 60 seconds at the bottom. So that said, all the units have canceled. I'm only left with what I want. Meters divided by second. That's the meaning of per second. Now, this type of problems, it checks for itself, right? You don't have to really worry because If your unit, if you don't see your unit canceling out, then you're doing something wrong. So at this point, you can multiply everything at the top, 17.2 times 1.609 times 1000, and you divide all of that by 60 times 60, which is 3600. If you do that, it gives you 7.6 meters per second. So 17.2 mile is a speed that was reported in America. So when you convert that into this one, another person understands it, but it is worth mentioning that the speed is the same. It's not like the person is now driving slowly or slower because it is 7.8. So it is the same thing. Now, this another one, you're converting gram per milliliter to pound per liter. So if you have your conversion factor, you're good, right? 1 pound is equal to 453.6, or you just say 454. And then we know that 1 liter is equal to 1000 milliliter. So because I want to convert from grams to pound, first I bring in my conversion factor that will enable me to do that, right? My 1 pound goes at the top because that's the unit I want, and my grams goes at the bottom because I want this gram to cancel with this gram right here. Okay. So when you do that, you now convert from milliliter to liter. So you bring in the conversion factor that will enable you to do that. Because my milliliter is at the bottom, I want to make sure that my 1000 milliliter goes at the top, right? So I make sure it goes at the top so that I can have milliliter cancel milliliter. So at this point, I'm good because I was looking for pounds per liter. So now my pound is at the top, my liter is at the bottom. So I have pound per liter, and I'm good. I can now go ahead and multiply my numerical values, 19.3 times 1000, and I divide all of that by 454. That gives me 405. That gives me 42.151, right? And to the right number of decimal will be 42.5 pound per liter. Good. So now try this one. Pause the video, right? Pause the video and try it. Take about 1 minute, I'm sure. Now, this problem is a little bit tricky, right? When they say centimeter cube, it is the same as saying centimeter times centimeter times centimeter. So if you know, right, if you know how to do your conversions, whatever you do, because it is cube, you're going to do it 3 times. For example, I know how to convert from 1 inch to centimeter, right? So 1 inch is equal to 2.54 centimeter. So I bring in that conversion factor, right? And I arrange it in such a way that they will cancel out. Saying centimeter is at the top, I make sure I put centimeter at the bottom. But I would do that 3 times because I have centimeter cube. If I had centimeter square, I would do it 2 times. If I had just centimeter, I would do it 1 time. But because I have it 3 times, I will bring in that conversion factor 3 times. I'll bring that conversion factor 3 times because I want the unit to cancel. So you see, when you bring it 3 times, you see this 1 centimeter cancels the first one, the second centimeter cancels the second one, the third centimeter cancels the third one, right? And you're left with 1 inch times 1 inch times 1 inch, which gives you inch cube. And so your final answer is in each inch cube. Take note, if you don't bring it the number of if you don't bring it the number of times that this unit is the number of time of the exponent of this unit, then your units will not cancel out, right? Because it is cube, you have to bring your conversion factor 3 times to make sure you cancel all of that unit and convert it to the required number of units. Okay. So the next one is this one. I want you to take some time, look at it, try it, try it. This sign means micro, right? So 1 foot is equal to 30.48 centimeter, right? You bring that in, right? And one thing I want you to see, this conversion factor has an error, which I'm going to fix. 1 meter is equal to 1 times 10 to the 6 micrometer, not -6, okay? That's a mistake. That's a mistake. It's to the 6, not -6. So if we bring that in, Now we're going to convert from feet to centimeter, and we'll take from centimeter to meter and from meter to micrometer. I decided to make it multi steps like this because I want you to understand. So we're going to take it. So because we have feet three times, I'm going to bring this conversion factor three times. So this is going to be a really long because we're going to do every step three times, right? That's one of the longest problems you can have. Okay. Now we've canceled all the feet. We're left with centimeter. Now we convert a centimeter into meter because we know that 1 meter is equal to 100 centimeter. So again, I'll bring that three times so that I make sure all the centimeter are cancelled out and are being converted to meter. Now I want to remember that micro, as you can see right here, micro means 10 to the negative 6, right? So micrometer means 10 to the negative 6 meter. Okay. So I bring that in, right? 1 meter, I bring that in. Again, make sure you correct this. It is not negative 6, right? It is 6. It's not negative 6, it is 6. Okay. So if you do that, it's going to give you 1.84 times 10 to the 40. So this is another multi-dimensional problem from pound per feet cube to grams per centimeter cube, right? So what I would do is I take one dimension at a time, I convert pound to grams, and I write everything as a fraction. Take note that the feet here is at the denominator, right? So you write feet three times at the denominator, but because I want to convert from pounds to grams, that I'm going to ignore that first. Then I convert from pounds to grams. 1 pound is equal to 454 grams. I bring that in first. And then I have converted my pounds to grams. Now I bring my relationship that enables me to convert from feet to centimeter, right? And I have 1 feet is equal to 30.48 centimeter. I bring that three times now because I'm dealing with a feet. So I want to make sure that these 3 feet will cancel with this one at the numerator. Okay. And so my answer is going to be gram per centimeter cube, which is 0.072. So that said, it brings us to the end of this section. Make sure you follow up with any question you have. We'll be more than happy to set up an appointment for you.